Hello, we are Group 6 of Advanced Computer Arithmetic course, and I am Javin Giovanni, and I am going to demonstrate our project on 64-bit carry lookup adder on behalf of our group, which includes Kishan Akbari and Yug Patel. So let's start with quick introduction of carry lookup adder. So carry lookup adder is fast adder designed to minimize the delay caused by carry propagation in the basic adders. The carry lookup adder doesn't depend on the previous carry, but it depends on the C in. So here is the basic calculation for the same. So carry depends on the previous generate and previous propagate. So here the generate is end of ith bit of x and y, and the propagate is the XOR of ith bit of x and y.
So now I will going to demonstrate 4-bit carry lookup adder. The left side of the screen shows circuit and equation for the 4-bit CL, and the right side shows Verilog for the same. Now first of all, we initialize the input and output which we use below. Now we have to first require G and P for all 4 bits. Here by using AND and XOR gate, we generate G and P for one bit. After that, we have to implement the equation for carry which shows left side of the screen. For the CLA logic, the current carry depend on the previous generate and propagate. By this logic, we generate carry for the first 3 bits by using AND and OR gate. For the 4th bit, we require the generate and propagate of 4 bit. For that, we have to exclude the C in part from the C4 equation. This G and P goes in 16-bit CLA. For the and the last, we generate 4-bit of sum. Now we are going to demonstrate 16-bit of CL.
So now in 16-bit carry lookup adder, first we initialize 16-bit of inputs and output for the same. A previous block generates G and P of 4 bits. In the 16-bit module, we required the same 4 bit to generate and propagate. For the first 4 bit, we used the instance 1000 to generate 4 bit of G and P. By using G0 to 3 and P0 to 3, we generate C4 and the carry of the 4th bit will go into the next 7 to 4 bit block, which shown in the left side of diagram. From the same concept, we generate C8, C12 by using provided 4 bit of G and P and the C in. Now we have to generate 16 bit of generate and propagate. For that, it is shown in left side of screen. We use the formula of the G15 0 and P15 to 0, which goes into output of 16-bit CL.
So now I will going to demonstrate 64-bit carry lookup adder. First, we initialize 64-bit of inputs and outputs. For the previous 16-bit of CLA, we get 16-bit of generate and propagate. To get the 64-bit output, we require 4 into 64-bit of CLA block. First, 16-bit generates 0 colon 15 bits of propagate and generate, which is only 1 bit answer. And by using the PNG, we generate C16, and the C16 goes into the next block of C16 colon 31 CLA. And by the same concept, we generate C32 and C64 by using previous 16-bit of GP and C in. And the last, we want to generate G0 colon 63 and P0 colon 63 as an output. To get this, we have to use 16-bit PNG. And the final we have to generate carry out. For that, the right side of formula we generate carry out with using only generate, propagate, and in. Hence, here we doesn't use any intermediate carry. So this is the 64-bit carry lookup adder test case. Here we use random function to generate the random inputs of A, B, and C in. So we get the random C in, random A, and random B input, and we run it approximate 10 raised to 9 times. In addition to, we checking if the expected answer is equal to we get the answer or not.
So we run the code in model sim of approximately 30 minutes, and we get this Excel as the output. So this Excel contains around 3 lakhs lines of 3 lakh 68,000 lines of output. So for that, program another code which is shown in the screen for measuring the delay. So here it is the code written in the C++ language, and here is some basic syntax of set, pair, and vectors. So we have calculated the delay. So the output is shown here. So we have approximately 21 we have calculated delay with approximately 21 different values. So we get the maximum delay of 249 when the inputs are this and this. And we get the output for the here we get the output this, and output is 0, and the carry in is 1. So and now move forward to the PPT. So here is the diagram, the 64-bit carry local error. So we get the maximum delay when every block generates and propagates the carry. And for the same we get the minimum delay when none of the blocks generate or propagate any carry. So let's conclude this presentation. Thank you.